Structure of a molecule like carbon monoxide. So the first step, we need to determine the number of valence electrons in the CO. We know carbon has a valence electrons of 4 electrons. We have oxygen has a valency number of 6 electrons. Total number of electrons to take to account for is 10 electrons. Number 2, of course, we have to arrange the atoms, looking for symmetry, and this is only 2 atoms, 2 elements. I mean, we have 2 elements, so it's just gonna be almost linear. I think it's just gonna be linear. Now the third step is to at least form a bond using 2 electrons. So those are the 2 electrons. So now you see we've used 2 electrons, so we are left with 8 electrons. Where will the 8 electrons go? Out of the 2, determine which one is more electronegative. When we talked previously in another session about electronegativity, you're looking for an element which has high affinity for electrons. Between carbon and oxygen, oxygen is more electronegative, so we're gonna give it its octet to make it comfortable. So now you see oxygen here is happy. It has 8 electrons around it. It's happy. But the carbon is not happy. It only has 2 electrons around it. So we need to give carbon more electrons. But see, all that we've accounted for right now is 8. So we are left with 2 electrons to account for. Since oxygen is an octet, let's give the rest to carbon. Now carbon has 4 electrons. It's missing 4. Now we know from determining the type of bond that should be in between carbon and oxygen is gonna be polar covalent. So now if one of the element is not having an octet, what we can only do is to share electrons. Okay, to share electrons by donating from oxygen to form multiple bonds in there. You do that, what you're gonna get is carbon and oxygen. Now you have 2 lone pairs after transferring 2 electrons and 2 lone pairs on oxygens. Then you still have the lone pair out there. So now you see oxygen has 8 electrons. Carbon has 6, so it's lacking 2. That means we need to donate 2 more. And you can pick whichever lone pair. You can pick that or that, bring it in the middle to share. So you do that, what you're gonna end up with is a carbon with oxygen with 6 shared electrons and 1 lone pair per element, carbon and oxygen. Now determine again the stability state. So oxygen has 8 electrons around it, and carbon has 8 electrons around it. So both of them are octets, so the molecule is happy. So that's the Lewis structure of carbon monoxide. Now if you are to draw the bonds, remember I told you 2 electrons that are shared form a bond, so you're gonna have a triple bond, right? So that's the Lewis structure of carbon monoxide.